Hello everyone. In this video, we are going to discuss about another example for conversion of given CFG into CNF. This grammar is given. So the first step is eliminate epsilon productions. So to eliminate epsilon productions, first we have to check is there any direct epsilon productions in this grammar. So here we have A tends to epsilon and D tends to epsilon. Okay, from A tends to epsilon and D tends to epsilon productions, we can say that A and D are nullable. Okay, so if you want to eliminate epsilon productions from the given grammar, first we have to find all the nullable symbols. So the basis step for nullable symbol is finding direct epsilon productions. Okay, from the direct epsilon productions, we can say that A and D are nullable. Then we need to check the body of the productions. Okay, if all the symbols or body of the productions are already known to be nullable, then we can say that head of the production is also nullable. So now we need to check is there any production contains only A or AD or alone in the right hand side of the production. So here AACD. AAD are nullable, but C is not nullable. And here terminal symbols are always not nullable. So only two nullable symbols in this grammar. Now we have to eliminate epsilon productions from the grammar. For that, first we have to rewrite the given productions except epsilon. So S tends to AACD bar. Now we need to uh, apply all possible combinations, okay, by considering the nullable symbol. So if we consider this D is nullable, we will get AAC, and if we consider this A is nullable, we will get ACD, and if we consider this A is nullable, then we may get again ACD that we have already written. Now we have to consider two symbols are nullables. So consider first two A's are nullable. A's are nullable, right? So we will get CD. Then if we consider one A and one D, this A and D are nullable. So we will get AC. Then if we consider this A and this D are nullable, so again we will get AC. So no need to write the same production again. Now we have to consider all the three symbols are nullable symbols. Okay, A and D, no? So A, D, all three symbols are nullable means we will get only C. Okay. So now we have to consider A. A tends to first write AAB as it is, and then don't write epsilon. Okay, now consider this A is nullable, right? So if you substitute A is nullable means we get AB. Then C tends to AC bar A, and here there are no nullable symbols. So we will get only the same productions. Then D tends to ADA bar BDB bar. We should not substitute epsilon. Okay. Now here D is nullable. So if you consider epsilon for this D, we get only AA. Then if you substitute epsilon for this D also, we get BB. Okay. So this is the first step. Now we will consider the elimination of unit productions. So second step, elimination of unit productions. So here first we need to find all the unit pairs from the grammar. So to find unit pairs, we know that a variable comma variable is a unit pair first as per the basis condition. So here there are four variables. So we need to write SS, AA, CC, and DD are unit pairs. Then we need to consider all the pairs one by one and check is there any new unit pairs generated based on the recursive step, okay, or induction step. So here S comma S. S comma S is a unit pair. Now we need to check whether the second symbol of the unit pair contains unit production or not. So S has a unit production, S tends to C. So it will form a new unit pair, S comma C, right? S comma C is a unit pair. So this we can write like the first symbol of the unit pair, comma, body of the unit production, C. Okay. Now consider this S comma C. Okay, recursively we have to consider. So S comma C. Now check whether the second symbol C has unit production or not. No. So we can leave it now. Then consider AA. This consider the second symbol A has a unit production. No. Then CC. Then check whether C has unit production. No. Then check DD. Okay. Check whether the D has unit production or not. No. So now we need to eliminate all the unit productions from the grammar. For that, we need to write the first symbol of the unit pair tends to non-unit productions of second symbol of the unit pair. Second symbol of the unit pair means all these non-unit productions except this one. This is the unit production. Okay. So we have to copy all the other non-unit productions. AACD bar, AAC, ACD, CD, AC. Then A implies, the first symbol implies non-unit productions of second symbol. So all the productions are non-unit productions only. So just copy. Then the first symbol of the unit pair C tends to non-unit productions of C. All the productions are non-unit productions. So just copy. Then D implies non-unit productions of D. All the productions are non-unit productions only. So AD A bar, BDB, AA, BB. Then this first symbol tends to non-unit productions of the second symbol C. So AC bar A. Okay, so now we have found all the non-unit productions. Okay, in this step, we don't find any unit production. Okay, so now we have to rewrite this because some productions are having some symbols are having more productions. Okay, we have two S productions here. Other productions are single only. So we have to combine this also here. So rewrite this. S tends to AACD bar, AAC bar ACD bar CD bar AC. Now combine this also. AC bar A. Now rewrite ACD as it is. AAB bar AB. Then C tends to AC bar A. So finally D tends to ADA bar BDB bar AA bar BB. Then we need to do the third step. The third step is elimination of useless symbols. So first we have to find all the generating symbols from the grammar. So by default, all terminal symbols are generating. Here the terminal symbols are A and B. So these are generating symbols by default. Then as per this is the basis condition for finding generating symbol. Then as per the inductive step, if right hand side of all the symbols of right hand side of any production or nullable, generating symbol, we can say that head of the production is also generating. Okay, if right hand side of the production is generating means we can say that the symbol on the left hand side of the production is also generating. So here, since A is generating, we can say that S is also generating. Then from this production, A and B are generating. Okay, all terminals are generating. So we can say that the variable A is generating. Then since A is generating, we can say that C is generating. Then since BB or AA are generating, we can say that D also generating. So C and D all are generating symbols. So there are no non-generating symbols in this grammar. Okay, so no need to eliminate anything. Now we have to find all the reachable symbols. So to find reachable symbol, basis condition is start symbol of the grammar is always reachable. So yes, yes is always reachable. Then as per the inductive step, if start symbol, if head of the production is reachable means we can say that all the symbols in the body of the productions are also reachable. So we can write A, C, D, A, C, D are reachable. Then the terminal A is also reachable. Then from since A is reachable, we can say that the terminal B is also reachable. So there are only 6 symbols. All symbols are reachable symbols also. So no need to eliminate any symbols here. Okay. So there are no useless symbols in this grammar. Okay. Then fourth step is we need to introduce new variables for terminals. So introduce new variables for terminal symbols with production body of length greater than or equal to 2. Okay. So here there are two terminals. Hereafter we have to refer this resulting grammar. So here there are 2 terminal symbols. So I'm going to introduce P for terminal A and Q for terminal B. Okay, we have to introduce a new variable that should not be already present in the grammar. Okay, so here P and Q are new symbols, so we can use. Now S tends to AACD bar AAC bar ACD bar CD bar AC bar. Now PC. Okay, instead of A, substitute P. Okay, because the length is 2. So PC bar. Here single terminal symbol. Okay, CNF supports single terminal symbol. So, and here length is 1. So we should not replace this terminal symbol. We have to write as it is. Okay, don't substitute A by P. Okay, then A tends to, so in all the productions, substitute P instead of A and Q instead of B. Okay, so P, A, Q. But the condition is length must be greater than or equal to 2. PQ. Then C implies PC bar A. Then D tends to PDP bar QDQ bar PP bar QQ. Then we have to do the fifth step. So the final CNF will be we have to break the bodies of length 3 or more with the break the bodies of length 3 or more into 2 by introducing cascade symbols, k minus 2 cascade symbols. Okay, so there is no change with the first 2 productions. So write P tends to A and Q tends to B as it is. Okay, Q tends to B. Then in this production, length is 4. Okay, body of the length of the body is 4. Okay, so we have to introduce 4 minus 2 cascade symbol. So 2 cascade symbol we need. We can write S tends to A. Instead of ACD, we need C1. Okay, so introduce a new variable C1 tends to the second symbol, and second symbol is A, And instead of CD, if we write CD here, again it will not be in the CNF format. Okay, CNF means a variable tends to two variables or a variable tends to single terminal symbol. So for writing CD, I need one more variable C2. So what is C2? C2 tends to CD. Okay. So I can write S tends to A C1. Okay. S tends to A C1. So what is C1? A C2. So what is C2? CD. So the meaning is S tends to AACD only, but we have splitted like this. So all the productions are containing only two variables. Okay. Similarly, this production also has three symbols. So for AC, we need one more cascade symbol, C3. Okay. Then CD. For CD, we have already written C2. So we can substitute C2 here also. Then here also length 3. So C4 tends to AQ. Okay. First symbol we can keep it as it is. For second and third symbol only we are introducing a cascade symbol. Then here also. So C5 tends to DP. Similarly, C6 tends to DQ. Okay. Here 1 to 3 are the suffix only. Okay. C1 is a single variable. Okay. So now S implies AC1 bar A AC. Instead of AC, we need to write C3. So AC3 bar ACD. ACD means AC2. AC2. So all are two variables. Then CD, AC, PC, CD, AC, PC bar A. Single terminal or two variables. Okay. Now A implies PA. A implies P. Instead of AQ, we have to substitute C4. So C4 bar PQ. Then C tends to PC bar A. Then D tends to P. Instead of DP, we need to write C5 bar Q. Instead of DQ, we need to write C6 bar PP bar QQ. Okay, so now all these productions are considered as the final CNF. Okay, CNF means not only these four productions from P tends to A, Q tends to B, and all these cascade productions, then these productions. Okay, all these productions are having either two variables or a single terminal symbol. So this is in CNF format. So this is the given CNF. This is the corresponding or equivalent to CNF for the given CFG. Thank you.